Hi everybody, Mr. Rubo here. And today we are continuing with 3.10, solving trig inequality specifically. So the last video, we looked at more of a graphic approach to it, but we can also use our old friend, the sign chart, just like we did in Unit 1 way back when. So the way it works is we want to, similar to how we did it before, make the inequality compared to 0. So either less than 0, greater than 0, less than or equal to 0, or greater than or equal to 0. And what we're going to do is we're going to set it equal to 0 first and solve for x. We may need a factor depending on how complicated the equation is. And then just like in Unit 1, we're going to create a number line who's with the solutions marked from step 1. So whatever you solve for in step 1, you're going to put them on a number line. But then you also have to include domain restrictions. So, my pen likes to not work. There we go. Domain restrictions. So if they say they want only the answers from 0 to 2 pi, which they do a lot, you got to include 0 and 2 pi as endpoints on your number line. Then you can sketch the graph of each factor. And then determine for each factor if they're just positive or negative, and then interpret the sign chart just like we would do previously. So let's do an example. So here it says, what are the values for theta? 0 to 2 pi. So right there, I know I'm putting 0 and 2 pi on my number line. And here it says, for which 2 sine squared theta plus sine theta is less than 0. So right there, compared to 0, that's good. So now we're going to solve this. So to solve this, I need to factor out a sine. So I get sine of theta and 2 sine theta plus 1. And I'm also going to set it equal to 0 instead of less than or 0. So now I get the two equations, sine of theta equals 0 and 2 sine of theta plus 1 equals 0. And again, we're solving for theta. So sine is 0 here and here, which would be theta would equal 0 or pi. And then for this one, I go ahead and solve it and say, okay, sine equals negative 1/2, right? Subtract the 1, divide by 2. And again, this one, I'm going to draw my triangles. Well, sine is negative down here and here. Negative 1, 2, negative 1, 2. Those are pi 6 reference angles. So then I'm going to say, okay, I'm in quadrant 3 with a pi 6, which means that I'm going to be at 7 pi 6 once I can draw this. Yep. So 7 pi 6, and then fourth quadrant would be 11 pi 6. So again, in terms of our steps, we're going to go ahead and say 0 to pi, 7 pi, to 11 pi 6. Okay. So now what I'm going to do is I'm going to put these on a number line. And what we're going to do that may be a little different than what you did before. One, we're going to include 0 and 2 pi, and then we're going to put all these on there. So 0 was already included, but then we have pi, which is the next number out of these 4, right? Pi is less than 7 pi over 6. Then we have 7 pi over 6, and then 11 pi over 6. Now, something you could do is you could go to the original function and start plugging in values in between each of these values. Totally a legitimate approach to this, but just realize sometimes some of these won't give you the nicest angles, right? We don't actually know how to evaluate something between pi and 7 pi over 6. There's not a nice angle there. So this is where the other approach of let's graph our two functions and look at those graphs and then determine what we have here. Okay. So when we look at sine of x, or sine of theta, that graph very nicely looks something like this, right? So we go up, come back down, and then here we go. And we just care about the endpoints and where it's 0. So we care about 0, 2 pi, and then here at pi in the middle where it's, what's it called? 0. So what I'm going to say is, okay, at sine of x, from 0, so at 0 it's 0, at pi it's 0, and I'm running out of space, so I might, that's fine. I'm going to do this. So let me just move this a little bit. To apologize for this. Let me just move this over a little bit. Oh, it didn't all come. That's okay. We'll redo some of this. So let me redo that. Boom. And then this was 2 pi. Right. And then this was 0. So at 0, we have a 0. At pi, we have a 0. And at 2 pi, we have a 0 as well for sine. And then we look, okay, in between, positive. And then it goes to negative. All right. We're going to do the same idea here for 2 sine theta plus 1. So for this one, amplitude is 2, midline is 1. So I'm going to kind of do a quick sketch, right? So we're going to start here at the midline, go up 2, come back down, then hit here, and then boom. And again, we're going to look at, we know these 2 points because we found them. It's 7 pi over 6 and 11 pi over 6. And then again, we care about what happens at 2 pi, but we'll get there in a second, and what happens at 0. So for the second factor, 2 sine of theta plus 1, we're going to go ahead and say, okay, it's from 0 to 7 pi over 6, it's positive. That's all the way. So positive, positive, 0 at 7 pi over 6. Then it's negative between, and then it's a 0 here. And then it becomes positive. Okay. So now what we have to do is, once we kind of figure out these 2 graphs, is we have to read this straight down. So at 0, we're at 0. In between 0 and pi, we have 2 positives. 2 positives make a positive. So between 0 and pi, we're positive. Now we just have to be careful here because this whole section is negative, which means this is negative, this is negative, this is negative. So when I look straight down from between pi and 7 pi over 6, a negative times a positive is negative. Okay, and then we keep going. Here we have 2 negatives in this section, which means this section is positive. And then finally, this last little bit between 11 pi over 6 and 2 pi is a negative and a positive, which means it's negative. So we now have our sign chart completed. We go back to what we were looking for, because after all this work, you may have forgotten. We want less than 0. Well, less than 0 means we want the 2 negative answers, 2 negative intervals. So our answer would be pi to 7 pi over 6, exclusive, right? So we don't want to include them, union 11 pi over 6 to 2 pi. All right. And there we go. There's our answers. All right. Well, thanks for watching, everybody, and have a good day.